Welcome back to the deep dive. This is where we really try to pull out the most important insights from, well, the huge amount of information out there.
That's the goal.
And today we're diving into what's genuinely new, what's groundbreaking in space and technology. We're looking at sources like excerpts from Space and Tech, latest news,
Hmm?
our mission basically to cut through all that noise, that constant stream of updates, and really pinpoint the things that are changing how we understand things, how we live. Look, we know you're busy, you want to stay informed, right? But without wading through endless articles.
Yeah, who has the time?
Exactly. So this deep dive, it's your shortcut. We're not just talking about innovation in some abstract way. We're getting into specifics. What's actually happening? Why does it matter? You know, those aha moments.
Right.
I'll be your guide trying to highlight the surprising bits, the core ideas that really jump out.
And I'm here to add some context. Connect these, specific, really cutting-edge developments to the bigger picture. You'll see how a breakthrough in one spot can set off a chain reaction elsewhere. It really changes our progress, our potential. What's fascinating isn't just what the discoveries are, but how they all weave together.
Okay, let's get right into it then. Some really compelling stuff from our sources recently. First up, something truly cosmic.
Ah, yes.
The James Webb Space Telescope, JWST. Big news lately, right? It confirmed its first exoplanet, LHS 475b, Rocky World, only about 41 light years away. So, okay, another planet. But what makes this one so significant?
Well, what's really fascinating here isn't just, ticking another box for exoplanet found. It's the detail we're starting to get.
Detail, how so?
JWST used its super advanced infrared tools to do what's called spectroscopic analysis, basically sniffing out the composition of its atmosphere.
Okay.
Now, the initial results didn't show a thick atmosphere, but the precision of that data for a small, rocky world like this, it's unprecedented.
Unprecedented, wow.
Yeah. It really opens the door to understanding what the atmospheres of Earth-sized exoplanets are actually like in ways we just couldn't manage before. It makes us rethink some assumptions, about how these atmospheres form or maybe how quickly they change.
So we're moving beyond just spotting them. We're starting to figure out what they're actually like, their air, their composition. That feels like a huge leap.
It absolutely is. We're going from mere detection to actual characterization.
And what does that mean for the bigger picture, like the search for life out there?
Well, it's a fundamental step, really, towards finding worlds that could actually be habitable. Before Webb, atmospheric studies were mostly limited to the big gas giants.
Right, Jupiter-like things.
Exactly. So now, getting even preliminary data on a rocky planet's atmosphere, that's monumental. It helps us refine our models. How do planets form? How do they evolve? It gives us better targets for finding biosignatures.
Biosignatures. You mean signs of life?
Potentially, yes.
Yeah.
Gases that wouldn't normally be there unless something living was producing them. So this is all about sharpening our focus in this, well, unimaginably vast cosmos.
Okay, here's where it gets really interesting for me. Thinking about how that discovery way out there in deep space, how it connects to things happening right here in labs, in tech companies, our sources also talk about huge strides in quantum computing.
Ah, yes, a very different frontier, but just as exciting.
For instance, IBM. They recently unveiled their Osprey processor, 433 qubits. Now, qubit sounds like sci-fi to a lot of us. What is a 433 qubit processor, and why is this specific leap important?
Okay, let's connect this. If you think about the bigger picture, this kind of processing power could, well, revolutionize so many areas. A qubit, it's fundamentally different from a classical computer bit.
Which is just 0 or 1, on or off.
Right. A qubit, thanks to quantum mechanics, can be 0 and 1 at the same time. It's called superposition.
Okay, still sounds a bit mind-bending.
It is. But it means quantum computers can handle exponentially more information. Now, 433 qubits might not sound like a huge number compared to the billions of bits in your phone.
Right.
But it's a massive step towards something called quantum advantage. That's the point where a quantum computer could do a calculation that's just practically impossible for even the fastest classical supercomputers.
Impossible how? Like, takes too long.
Exactly. Takes thousands, maybe millions of years for a classical machine. The immediate impact of Osprey. It's likely in complex simulations.
Simulations like what?
Imagine speeding up drug discovery. simulating how molecules interact with incredible detail, something we just can't do now.
Yeah.
Or designing brand new materials with properties we haven't even thought of yet.
Wow.
And it could dramatically improve optimization problems. Think logistics, getting packages delivered faster, finance, managing risk,
Yeah.
even artificial intelligence. It really highlights just how fast computational power is accelerating.
That's incredible. So machines that could solve problems that would take regular supercomputers like ages, millennia maybe?
Potentially, yes.
It really feels like unlocking whole new ways to tackle some of our biggest challenges. And if you're finding these kinds of insights as fascinating as we do,
Hmm.
and you like how we're breaking down these complex ideas, please do hit that like button. And subscribe to the Deep Dive. Your support genuinely helps us keep bringing you these deep dives.
It really does.
Okay, speaking of interconnected progress, let's bring our focus a bit closer to home. Earth orbit. Satellite technology.
The LEO constellation.
Exactly. Low Earth orbit. Our sources mention these huge constellations all the time. Thousands of satellites being launched. It's changing global connectivity pretty dramatically.
Yeah.
What's driving this big push, and what's the actual impact of these networks?
Well, this raises a really important question, doesn't it? What's the real-world effect on you when we talk about all this stuff happening in orbit?
Right.
So, unlike the old geostationary satellites, which are way out there and have noticeable delays.
Yeah, that lag on satellite internet or calls.
Precisely. LEO satellites orbit much, much closer. This drastically cuts down the latency, the delay. It makes internet access feel fast, responsive, almost like fiber optics.
Yeah.
Companies like Starlink, OneWeb, they're deploying these networks to offer broadband internet basically everywhere, especially places that are remote or haven't had good service before. The impact is huge. It helps close the digital divide. It lets businesses operate globally with better connections. And it enables new stuff like real-time remote sensing, monitoring crops, responding to disasters, tracking climate change from space.
So space tech is directly touching our daily lives, our economies right now.
In very tangible ways, yes.
So it's not just about getting internet to remote cabins, though that's important. It's like a whole new layer of internet infrastructure affecting pretty much every industry.
That's a good way to put it.
But hang on, thousands of these things going up?
Yeah.
Does that cause any near problems, concerns?
Absolutely. It's not without challenges. All that traffic increases the risk of collisions, creating more space debris. That's a serious issue.
Space junk.
Exactly. And then there's light pollution. Ground-based astronomers are concerned about streaks from satellites interfering with observations.
So are they addressing that?
They are. Companies are actively working on ways to make satellites less reflective, better ways to manage orbital traffic. Plans to deorbit satellites responsibly at the end of their life is a dynamic situation, definitely complex, but the benefits are seen as so large that the industry is pushing hard to find solutions.
It's those aha moments again, isn't it? When
Yeah.
you connect these dots, exoplanet atmospheres, quantum processors, global satellite networks, you see this bigger picture, this
Yeah.
web of like accelerating innovation. It's not just one thing here, one thing there.
Precisely. It's all feeding into each other in often surprising ways.
So, okay, what does this all mean for someone just trying to stay informed? It's moving so fast. How do you tell what's a genuinely big deal versus just, an incremental update? It can feel like trying to drink from a fire hose.
It definitely can be overwhelming. There's just so much information. I think what's crucial is trying to take a structured approach. Look for the underlying trends. Ask, why does this specific headline matter?
Right. Context is key.
Exactly. Not every new finding carries the same weight. Understanding the context, the implications, that's vital. And honestly, that's what we try to do here. Help you filter through that flood of information to connect those dots we keep talking about and really present the aspects that have the most impact, the most relevance to you. We focus not just on what happened, but why it fundamentally matters, why it changes things.
Absolutely. We want to be your co-pilots, navigating through what's new and what's coming next, making sure you're informed, but hopefully not overwhelmed. And if this approach works for you, if you find it helpful, please take a second right now, hit that like button, maybe share this deep dive with someone who'd find it interesting, and definitely subscribe to the deep dive.
Please do.
Your support really does make it possible for us to keep doing this, keep bringing you these insights so you can stay ahead of the curve.
It helps us keep the lights on, so to speak.
So as we wrap up this particular deep dive, looking back at these excerpts from Space and Tech, latest news, it's just so clear these aren't isolated events.
Not at all.
From JWST peering into alien
That's
atmospheres,
angering stuff.
to IBM unleashing quantum power with Osprey,
Game-changing potential.
to these LEO constellations blanketing the globe with high-speed internet.
Reshaping connectivity.
We're just in this period of incredible acceleration. Science, technology,
Yeah.
it's dynamic, it's interconnected, and it's constantly reshaping our world and, well, our place in the universe.
It really is. And considering this sheer pace,
Yeah.
the speed of these developments we've just talked about, it really makes you wonder, doesn't it?
Wonder what?
What's the next big breakthrough? Something we can barely imagine right now. What might become major news in just a few years? How could our daily lives, our economies, maybe even our basic understanding of reality, how could that shift because of discoveries we can't even conceive of today?
Wow, that is definitely a mind-expanding thought to end on.
Something to chew on.
For sure. Well, thank you for joining us on this deep dive. We really hope you feel a bit more connected and definitely more informed about this incredible, fast-moving world of space and tech.
Hope it was useful.
Don't forget to subscribe so you catch our next deep dive. We'll keep exploring complex topics, making them clear, concise, and hopefully pretty captivating just for you. Until next time, keep digging deeper.